Hello everyone, thank you for tuning in. In my last video I covered the basics of how signals work at the simplest level. And in this video I'd like to start talking about some more advanced concepts, both how to use some of the other signal types and also some simple and at the end of the video slightly more advanced station design. So right here, to start off with, we're going to talk about the signals. So on this first track that I have here, you have your basic signals. You have just the standard block signals. And the way that those operate, like I talked about in the last video, is if there is a train on the block that the signal is representing, then the signal is going to be read. So the block of track that this signal, this first one, represents are these three pieces of track. And there's a train right here at the end of it, so this is a red signal. And obviously this signal is going to be red as well, because this train is directly on top of it. So this is a signal that is new in this video. It is an exit signal. Exit signals operate, for all intents and purposes, exactly the same as block signals do. So you can see here, just like the block signals, both of these signals are red. So moving on to entrance signals here. So exit signals are on the signal selection window, the third one right here, the one with the white or gray vertical line. Entrance signals are the ones with the yellow horizontal line. So entrance signals operate exactly the same as a regular block signal, but with one exception. They have an extra scenario in which they can be read, which is if there are exit signals on the block behind that entrance signal, then the entrance signal will be read if all of those exit signals are red. So you can see here that there are two exit signals on the block represented by this entrance signal, and because both of these exit signals are red, this entrance signal is red. You don't see any trains inside of the blocks represented by this entrance signal. There's nothing that, if this was a regular signal, this would not be a red signal. But because it's an entrance signal, and because both of these exit signals are red, this entrance signal is red. So you can see here, when you have one of the exit signals being green, the entrance signal turns green. So the benefits of this signal and the application of the signal might not be obvious right away, but because of that, we'll go on and start talking about some practical implementations of these signals. So you can see here, this is a basic what's called RoRo station, or roll-in, roll-out station. And the reason that it's called that is relatively obvious. You can see train rolls in, and then when it wants to exit, rolls on out. Doesn't have to turn around or anything like that, just goes in, goes out the same way. So you can see the signal setup here. I have an entrance signal right here, right before the decision of which track it's going to choose is made. And then you have exit signals in front of one exit signal for each of these platforms. And then behind the platforms you have a default signal, one behind each of the platforms. So you can see that anytime that the first train comes in, or anytime that a train comes in and none of the platforms are being used, they always go to this platform right here, the one on the bottom. But if this platform is occupied, then it turns this exit signal red, and it forces other trains to go onto this platform. And if both of the platforms are occupied, then both of these signals will be red, and it'll turn the entrance signal red, and trains will have to wait outside and behind the entrance signal before they can get in, which is what you want, because when you do that, it forces the train to wait before it makes a decision, right? So it forces the train to wait until it knows which platform is going to be open before it decides which platform it's going to go to. If it were to just, if this entrance signal stayed green while both of these platforms were occupied, the train would choose one of these tracks. It wouldn't know which one it should choose because it wouldn't know which platform is going to be free first. So as a result, you want trains to wait until they know which way to go, else you're just going to have longer delays. So moving on to the other station in this little network is the terminus station. Now this is, as I say here, it's bad terminus design. A terminus station is basically just where the line terminates and a train has to turn around to exit the station. So the way that it's set up is you have an entrance signal here, and then you have two-way exit signals in front of each of the platforms. Two-way in this scenario, of course, meaning that there's one signal facing each way on the track. So there's some pretty significant issues with this terminus design, especially if you're using high volume if you have a high volume of trains coming back and forth. Mainly, that trains are unable to enter while another train is exiting, or another train is unable to exit while another train is entering, which you can see here, despite the fact that this train is exiting straight out and not taking up any of this track, because of the way that the signals are set up, and because of just because of the way that the track is set up, because of the way that the station is designed, all of these tracks become locked up right when any train is moving across them, and as a result, despite the fact that it was safe for this train to enter, it wasn't able to enter while this train was exiting. So, that's not that big of a problem if you don't have a high volume of trains coming in and out. But once you start to get your sort of more, advanced networks, or just networks with a lot more trains on it, then you're going to want to start avoiding terminus design like this. And I would say for the most part, you pretty much always are able to use a roll-in, roll-out station. But if you do feel like using a terminus, only use this design if it's going to be low volume, or else you're going to start running into issues. If you really, really want to use a terminus, either because you have to or just because you want to be fancy, then there are good terminus designs, which I'll show you one of those right now. So the roll-in, roll-out here, exactly the same, but the terminus here, you can see, is significantly different. You have a dedicated line here for entrance, and a dedicated line for each of the platforms for exit. So you can see that when this train comes in, it just goes straight out. Then when it exits, it doesn't use, or it doesn't share any of the track that it used previously. And you saw right there a train entering while another train was exiting. Again, train entering while another train is exiting. So this terminus actually has extremely high throughput. It has a very, very, or rather, it's really good at getting trains in and getting trains out and not taking up extra track in scenarios that it shouldn't. Sorry for the cut, you guys, right in the middle of the video, but I recently realized, and by recently I mean just a moment ago, realized that when I click the fast forward button, it actually stops recording video, or at least my computer can't really handle it, so that's a bit of a shame. But what I was saying before the cut was that the throughput of this station actually makes it so that it is, in fact, more efficient than this one, than the RoRo. It actually, it doesn't ever have any delays, whereas right here you can see that there's very, very slight delays at the roll-in, roll-out station, which is completely different from the other terminus. Like you can see right here that with this terminus, there's always delays happening here. With this network, this terminus is the biggest sort of bottleneck of the entire network, whereas right here it's actually turning into the RoRo, which is the bottleneck. So with some clever station design, you can really, really improve upon designs that you might not have thought that you would have been able to, and you can come up with some really clever stuff. And I would say if you find this type of stuff interesting, just go onto the OpenTTD wiki, or the OpenTTD co-op wiki, and just look around there. I'll throw a link to it in the description of the video, but that's where I learned most of the stuff that I know. There are a bunch of geniuses there, and I think it makes the game more fun to play. But for now, that's about all I've got. Next video, I will be talking about junctions and more advanced networking, but thank you for tuning in, and I'll see you next time.